All right, we're going to be getting into our next presentation here. As we know, running modern software can be hard, and it can be even more difficult to keep things secure and maintainable. There are different approaches that are necessary, different life cycle phases of the application delivery process, whether you are building or actually running your software on a platform like Kubernetes. And here today, we've got two awesome speakers from Accenture, Anand Parulkar and Mahesh Bankar, coming to join us to talk about understanding the security landscape of Kubernetes with VMware Tanzu. Super excited about this. Take it away. Yeah.
Hello, everybody. Welcome to Spring One. I'm Mahesh Bankar, and with my colleague Anand Parulkar, we are going to talk about how Tanzu offerings can help in Kubernetes security. Let me give a brief introduction about what security do we need in the current scenario. You're already aware that cyber threats are becoming more and more sophisticated, and that is the prime reason we need to secure our cloud landscape. Your applications and the infrastructures that they are running on are already a target for cyber criminals. The evolution of modern software has brought us the containerization of applications and also the popular container platform, Kubernetes. Security is important throughout the container lifecycle due to the distributed and dynamic nature of Kubernetes cluster. Different security approaches are required for each of the three phases of application lifecycle. Say build, deploy, and runtime. During each of these phases, there are opportunities to remediate vulnerabilities. In this session, we'll explore how VMware's offerings, Tanzu Machine Control and Octarine, helps us take advantage and go beyond Kubernetes innate security capabilities. What we are going to touch upon in this today's session, we will touch upon the overall Kubernetes security landscape. Then we are going to touch upon DevSecOps, the Kubernetes security posture. Then we are going to talk about the TMC and Octarine offerings that we have been that have the security posture implemented. Then we have authentication strategies and service mesh. Now, let us begin to talk about how the Kubernetes security landscape is overall structured. Okay, as you can see on the left-hand side, if you can see on the left-hand side, we have a source code, which is in Git or any source code repository. We need to package this source code. It needs to be stored, and then it needs to be deployed into our environments. And these environments need to be monitored. Now, access needs to be provided to people only on need basis, and the users will have specific roles. Now, let us talk about individual components within this landscape. First, moving on to Tanzu Build Service. What is Tanzu Build Service? It is offered by VMware to automate the container creation based on the source code. It integrates very nicely with Git. Second is Harbor. Harbor is an open source registry that secures artifacts with policies, role-based access control, and it also ensures images are scanned and are free from any vulnerabilities. It can also sign images as trusted so that any downstream application can use it. Through continuous deployment here, we will be able to deploy these images as containers within the Kubernetes environments. These are which are supported by Tanzu. The various policies will either be done via TMC or through Octarine, and this will be applied onto this Kubernetes environments via the platform operator. Now, what is TMC? TMC is a management platform, actually a SaaS offering, which provides a single pane of glass to manage our lifecycle of the Kubernetes clusters. What is Octarine? Octarine it's actually a specialized continuous security and compliance platform for Kubernetes workloads. Identity and access management is all about providing the right access to the right people, and we'll touch upon it in the authentication strategies. Moving on to execution, we have got TSM, which is built on top of Istio and enables cross-cluster communication across the microservices using global namespace concept. And finally, we have the visual interface of the console through which users will be able to monitor these various environments. Let us now deep dive into each one of these parts. Now we are going to talk about Tanzu service, TBS, and Harbor. Now on the left-hand side, as you can see, we have got the source code, which we have built. And the source code is dependent on packages, and it is also dependent on libraries. Now, these libraries could have vulnerabilities, which are periodically fixed and released as different versions. Now, what would happen in that case is we will have to build them so that our final container image does not have any vulnerabilities. That is where TBS comes into picture. Now, TBS integrates seamlessly with Git, and it supports common languages like Java, .NET Core, and other platforms. It also supports image registries, common image registries like Harbor, then cloud service provider image repositories like for AWS, GCP, and Azure. What it actually does is it uses cloud native build packs and K-packs to intelligently convert your application source code into Docker compliant images. It also includes a powerful team-based permissions model, which the platform operators can make sure that only the developers can use these build-back configurations only that are routed to them. And finally, it can rebase your app images when your base images are updated in the registry. What does this mean to you? It means that we can resolve certain common vulnerabilities and exposures, which is CVE, without a rebuild. Now, it's a very important feature for Tanzu service. Now, once the container is built in Tanzu service, you move on to the image registry, where your images will be stored securely. What is Harbor? Harbor is a CNCF graduated project. It delivers compliance, performance, and interoperability to help you consistently and securely manage these artifacts across cloud-native compute platforms. Harbor can scan images, and it can prevent images with vulnerabilities as well. Harbor provides static analysis of your vulnerabilities through the open source projects Trivi and Claire. When we run vulnerability scans on the images, we can identify on the basis of the severity of the vulnerabilities, whether we want to deploy this into your Kubernetes environments or not. Now, this is where the individual settings would come into picture. For a dev environment, we will not have that stringent requirements. So we will allow some of these, we will whitelist some of these vulnerabilities for the development environment, but we will not allow it for the production environment. Now, these settings obviously will differ on the basis of the environment. Moving on to the next part is the operations part. Now, here we have got TMC and Octarine coming into picture and the Kubernetes environments. Now, TMC is actually a management platform. It easily allows us to provision clusters, manage and apply policies, and also inspect clusters. You can upgrade your Kubernetes clusters and it integrates seamlessly with other Tanzu products like Tanzu Observability and Tanzu Service Mesh. You can also create or schedule a backup of your Kubernetes environments so that in case you want to restore them back, you can do that as well. Now, Octane, what does it do? It embeds your DevSecOps into the complete lifecycle of application environment. Okay, right from pre-production through runtime. It protects code and configurations through Octarine guardrails for developers and adds network visibility and threat remediation at runtime. It protects applications on the cloud and also on the multi-cluster environments. Now, both the products provide out-of-the-box policies, policy creation, policies application, and monitoring. And TMC applies policies across clusters or namespaces and allows inspection of workloads. Octarine also has a lot of out-of-the-box policies, which you're going to see in the next slide, and it can give us good control over the security posture of Kubernetes and rank threats by urgency. It allows enabling encryption, segmentation, and network security policy enforcement for network service communications. Now, moving to the Kubernetes environments, TMC provides support for TKG, which is in-house built Kubernetes, in-house offering of Kubernetes from VMware Tanzu. And it also supports managed Kubernetes from AWS, GCP, and Azure. It also supports, you can also attach Kubernetes clusters, which are custom Kubernetes as well. Once this is done, then we move on to the execution part, the Kubernetes security posture part, where we have classified what all things do you need from your security policies. As you can see, we have classified it into 6 parts. The first part is RBAC. Now, the first and foremost thing about Kubernetes security would be to prevent or to regulate your access to your cluster environment. How do we do that? We have role-based access controls, where we can have this certain user with only this particular roles, and those will be done via the cluster role bindings. Next is network. Every pod will have to communicate, or most of the pods will have to communicate with the outside world. Now, in that case, do we need to monitor them? Yes, because that is where we will have security challenges coming into picture. Now, with these policies, you can ensure that service types like load balancers, host ports, and node ports, these are not exposed outside of Kubernetes unless they are needed for. Third is the volume part. Now, every pod or every workload that we have will need access to some sort of file system where it is going to keep your keep the data secure. Okay, so we can provide limited access to the file system and volumes, only read-only access, and somehow prevent this pods to only access the things that they need, not have anything else over and above what they are actually waiting for. Third is runtime security. What happens if like we have a container running and somebody is trying to exec into that particular container? Now, we don't want all these things to happen in runtime unless and until it is approved. So we can have policies which will block your execution to exec to a container or port forward. It can also deny latest stack containers, because we don't want every latest image being put into the Kubernetes environment. And we can also limit their access to the namespaces. It can also scan images and prevent deployment of images based on vulnerabilities. The fifth part is CRD, custom resources. Now, do we really want custom resources? Unless and until there is a certain development that is going on within our project, we could limit any other types of CRDs being deployed into our Kubernetes clusters. And sixth is quota. Obviously, every pod that is running on needs to have a certain limit on the memory and CPU. It cannot hog onto the entire part, which is the entire memory or CPU that is available from that particular VM. Now, this is where it will ensure that every pod has limits within the configuration. Now, how does Tanzu Mission Control and Octarine do this? Now, TMC, you can provision your clusters, you can group your clusters according to your namespaces. In Octarine, you can define your scopes for clusters, and you also have an health dashboard. Both of them allow attaching clusters so that you can view them on your console. Now, TMC also provides from a security policy features. Now, these are where all the cluster management features. We also have security policy features that come into picture. TMC provides standard conformance pack execution, which are primarily CIS benchmarks and Kubernetes specific policies. And Octarine has specifically scan images, command line, policies that we saw earlier, CRD, monitor image repositories. What both of them provide is out of the box quota policies, workload security, violations, images, and RBAC access and network security. They also allow us to provide custom policies. In TMC, they are applied via the OPA, Open Policy Agent, and in Octarine, they are applied via Maple. Finally, in Octarine, we have got whitelist. You can also whitelist your violations, and you can say that, okay, this is the violation that I do not need. For a better features comparison, this is a table that is provided where we have grouped this according to security features and how do TMC and Octarine actually go through each one of these policies and where all the differences are there. As you can see, primarily the custom one, OPA-based policies and Maple-based policies in Octarine. Now, with this, I would like to hand over to my colleague Anand Polkar for authentication strategies and secure and service mesh.
Hi everyone, this is Anand Parulkar, and today I will walk you through or talk about a couple of key areas: identity and access management and service mesh. So getting into identity and access management, why this is needed, especially in the Kubernetes context. Let's first understand that before jumping into what is OIDC and what is DEX. So when we use Kubernetes, a developer using kubectl command line or using UI dashboards, eventually they end up using API server of Kubernetes to create objects or remove objects, update objects like pods, deployments, replica sets, namespaces, and so on. And basically, there is a concept of cluster role binding. So a particular role is given to any user identity, and accordingly, necessary permissions are granted for different actions that need to be performed by the user on the Kubernetes cluster. Now, for a Kubernetes API server to trust an incoming user identity, there are several ways to do that. As you can see on the slide, there are very basic mechanisms like X509 certificates, using which client has to use certificates to get authenticated. We could use bearer tokens. Those can be used in a static token file, and that file resides on a node which API server runs on, or we could use HTTP basic auth and so on. But I mean, there are issues with each of these mechanisms because, for example, if we use certificates, they get expired every 3 months or 6 months. If you use a token file and for any new user addition, if you append the tokens in that file, you will restart API server, you will restart nodes. So there are always some issues with each of these mechanisms. That's why we are thinking about OIDC or OpenID Connect. Now, what is OpenID Connect? OIDC is a layer, identity layer, which is built on top of OAuth 2 protocol. So every one of us know what is OAuth 2. So OIDC is nothing but a layer built on top of OAuth 2. And clients basically use OpenID Connect to verify end user identities based on the authentication performed by the authorization server. So let's get into more details of OIDC. So there are a couple of examples or a couple of implementations of OIDC, which you see on the screen. One is DEX, other is Keycloak. Both are open source projects. Talking about DEX, DEX is an identity service which uses OIDC to drive authentication for external applications, including Kubernetes. That's why we are discussing it today. And the beauty about this is DEX itself can use connectors to delegate authentication to upstream identity providers, as you can see on the screen, which could be established identity providers like GitHub, Okta, or any LDAP server or SAML provider. Okay, so that could be done with DEX. And the way it works is we install a DEX service as a service which runs as a pod on a Kubernetes cluster, and then DEX configuration contains information about which connectors we need to use and which OIDC providers can be linked to that particular DEX instance. So the benefit of all this is, first of all your users are centrally stored in your OIDC provider. Nothing is on the Kubernetes cluster. And what happens is when you log into these OIDC providers like Okta, GitHub through DEX, then you get back ID token, which is signed by DEX. And this ID token itself can be used as a bearer token to log into Kubernetes. So, and the next question is, why would the API server trust the incoming ID token as a valid user? Because Kubernetes doesn't know about this user store or OIDC provider. But that's why DEX was introduced as an intermediate layer. Since we installed DEX on Kubernetes, a Kubernetes API server will have the public keys of the certificates that are issued by DEX, and using those public keys, whenever any ID token is signed by DEX and returned back to API server, Kubernetes will trust it as a valid user identity. And then we could use Tanzu mission controls access policy feature or Kubernetes native cluster role framework to assign specific cluster roles to those user identities, and accordingly the permissions will be are granted to those users. Now again, the benefit is for multiple Kubernetes environments you could have a single OIDC provider as well. In the previous approaches, what you saw was for every Kubernetes environment you will need to maintain the token files, clients would need to maintain certificates and all of that. Here you could actually use a single OIDC provider environment like Okta in this case, or GitHub, and you could connect multiple Kubernetes clusters to that through DEX. And this really simplifies user management, authentication, and with the tools like Tanzu Mission Control, you could very easily map an access policy to that, or you can very easily map a cluster role to any of the user identities which are coming from Okta, and that makes life very easy for the administrators from authentication and authorization standpoint. If you could go to the next slide. This slide talks about feature comparison between DEX and Keycloak. I talked about DEX, but Keycloak is another similar open source project developed by CoreOS, and it's soon becoming part of Red Hat SSO, which does similar, which offers similar features. So it is again it uses OIDC. It can connect with Kubernetes and upstream OIDC providers. Pretty much all the features are common except the last two, which I will quickly mention. One is the web UI. So in case of DEX, we need to do all the configuration on the command prompt in config files. And email is supported as the default claim. Claim is nothing but user ID for Kubernetes. So whatever claim we specify, that is identified as a user ID for Kubernetes. And to that, we can map cluster roles. Whereas in Keycloak, you could assign any of the user profile attributes as custom claims. So yeah, so that pretty much covers the identity management aspect and how DEX and Keycloak type open source projects supporting OIDC can be used to manage this authentication, and how TMC can be used to control the authorization. Let me move further and get into Istio, Service Mesh, and TSM. So Service Mesh itself, what is a Service Mesh? Service Mesh is a platform layer which is on top of infrastructure layer, which enables, I would say, secured, managed, and observable communication between individual services. And Istio is a open source implementation of Service Mesh to manage the east-west traffic connectivity across your microservices running on a cluster. Istio provides three main features. One is traffic management, security, and observability. I will quickly talk about these three. What I mean by traffic management, using Istio, you could specify traffic routing rules and control your traffic going to different versions of services. We could achieve blue-green deployment using Istio's Service Mesh traffic management rule. You could also achieve high availability failover type of features. In security, since Istio provides underlying communication channel between services, it can manage authentication, authorization, and encryption of service communication at scale. We could enforce consistent policies across different runtimes and protocols with very minimal application side changes in Istio. And when we use Istio with Kubernetes network policy, we could secure pod-to-pod or service-to-service communication at network and application layer. And with observability, we talk about logs, traces, and metrics. So Istio can generate traces, logs, and you could capture these and view in a tool. You could use open source tools like Kiali or Zipkin, or you could go with Tanzu observability itself, which is a part of Tanzu stack, in which you can collect your metrics traces coming in from Istio and show it on the console. Now, why Tanzu Service Mesh? So we talked about Service Mesh, we talked about Istio. Tanzu Service Mesh is built on top of Istio, its underlying uses Istio, but it offers a very nice feature of global namespace. Global namespace is something using which you could actually connect microservices running across very different Kubernetes clusters in different environments. With Istio, only services running in one cluster can talk to each other, but with Tanzu Service Mesh global namespace feature, you could connect services running across different Kubernetes clusters, which may be hosted or provisioned on different cloud providers as well. So that is the beauty of TSM. And using Tanzu Service Mesh dashboard or administration console, you could actually monitor how traffic is flowing from one service to other service, is there any issue in terms of response time, latency. So you can do some performance checks, you could troubleshoot issues with TSM console. And Tanzu Service Mesh is a SaaS offering by VMware, and using Tanzu Service Mesh, we could onboard any number of Kubernetes clusters onto it. And when we onboard a cluster in TSM, it automatically installs Istio on those clusters. And then you could specify your namespaces and services which need to be part of this whole global namespace. And automatically, all those services start communicating using core Istio principles, including security and encryption. All the traffic that is communicated is encrypted because Istio TSM installs SSL certificates at each API endpoint. So everything is secured and you could observe it in a TSM UI console or dashboard. So so that's all about service mesh, Istio, and how Tanzu service mesh adds further value on top of all this. Okay, so with that, I end my presentation here. Thank you very much for joining our session today on this topic, and see you in the Q&A session next.
Thank you, everybody.
Thank you.
Thank you, Anand and Mahesh, for that awesome presentation covering all of the intricacies of security on Kubernetes. If you are joining us today, make sure to get over to the Slack channel. There is a Slack channel for this talk specifically. All of them are hyphenated. It's Session Security Landscape of Kubernetes with Tanzu. We've got a Zoom link in there so you can join our speakers for Q&A. And once again, just thanks so much.